How do I use the angle sum theorem to find angle measures? All right, so before that, let's talk about an angle. An angle is formed by two rays. Bless you. Angle is formed by two rays. All right, there's a picture of an angle. Every angle has a vertex. That's the end point of the rays that form the angle. So in this case, the vertex is point A. This angle is made up of ray AB and ray AC. Okay, ray AB and ray AC are sides. Those are the two sides of this angle. This region in here is called the interior of the angle. This region out here, that's called the exterior. Now, in this case, when you're only dealing with one angle in a picture or a graph or a graphic display of an angle, you can name this angle just using the vertex. You could call it angle A. It's the only angle in the picture. All right, you could also name it angle BAC. A third name for this angle could be angle CAB. When you're using one letter to name an angle, that letter has to be the vertex. When you're using three letters to name an angle, the vertex has to go in the middle. That's real important. When naming an angle, using 3 points. The vertex. Must be the middle letter. Questions? Okay. All right, don't write this down. You're just gonna look at the wall for a minute. We're gonna talk. Okay, how many angles do you see on the wall? Yes? 3. Does everybody see 3? You see angle 1? Do you see angle 2? And then do you see the combination of those 2 angles? Okay, those are the 3 angles. Alright, so angle 1. One name for angle 1 in this case could just be angle 1. Alright? What's another name for angle 1? ADB, good. What's another name for angle 1? BDA. Can I call angle 1 angle D? No, because D is the vertex of 2 other angles, isn't it? Okay? So angle 2 has a couple other names. What's one of them? BDC. And the other one? Good. All right, then you got the big angle around the outside. What's that called? Well, no, just the big angle that's formed by the 2 small angles. It's going to be angle ADC, right? And what's another name for it? CDA. Everybody okay with all that? All right, very good. Okay, so let's get this in your notes, angle types. All right, we've got acute. Ooh. Okay, and that measures less than 90 degrees, doesn't it? And then a right angle. And that measures equal to 90 degrees. An obtuse angle greater than 90 and a straight angle that's equal to 180. It's a straight line. All right, and when you get that, you can turn the page. And I'm on the top of page 22. Congruent angles. Congruent angles have the same measure. Symbol. The symbol for congruent is an equal sign with a little squiggly line over the top of it. If you've got an angle here on the left, we'll call it M and O. And another angle on the right. ABC. If you remember the red tick marks from last week, the little red tick marks on the segments meant that the segments were equal to each other. When you're dealing with angles, this little red mark in the corner and they call them arc marks. Arc marks. Those are called arc marks, and they mean the same thing as tick marks. So based on this picture, you could say that angle N is congruent to angle B. Any questions? All right, let's talk about the angle addition postulate, and then I'm going to give you your assignment. Angle addition postulate. The angle addition postulate states that if S is in the interior of angle PQR, then lowercase cursive m means the measure of angle PQS plus the measure of angle SQR is going to equal the measure of angle PQR. And then we'll draw a picture of it, and it'll make way more sense. So let's draw a picture of S being in the interior of PQR. So we would need PQR. There's P, Q, R. Vertex is always in the middle of the description. If we put S in the interior of that angle, you can put S anywhere in here you want. And then take a ray and put it through S from Q. We've now created three angles. So the postulate says that if S is in the interior of PQR, S is now in the interior of PQR, then the measure of PQS, the measure of PQS, which is right here, PQS, that angle, plus the measure of SQR, SQR is this angle, the measure of the red angle plus the measure of the blue angle, that's going to equal the measure of this entire angle, won't it? Which is PQR. All right? So if we were doing colors, red plus blue equals lavender, fuchsia, I don't know, purple, whatever. Purple? Got it? Just like segment addition postulate last week. One piece of the segment plus the other piece of the segment equals the entire segment. All right? What's purple minus red going to equal? Blue. What's purple minus blue going to equal? Red. Okay? Very simple. So now, if you were given something like x and 2x, and you were told that the measure of angle PQR equals 60, and you're asked to find x, the measure of PQS, and the measure of angle SQR. You can do that by setting up an equation, right? In this case, purple is 60. So your equation would be x plus 2x equals 60 degrees. The red angle plus the blue angle equals the purple angle. And you're told that the purple was 60. So you can combine like terms. So 3x would equal 60. You would divide each side by 3. X would equal 20. So if x is equal to 20 degrees, or 20, PQS would be equal to 20. And SQR would equal 40. Very good. Okay? And just be careful when you're reading the question that, or when you're setting up your equation, okay, make sure that you got everything, small angle plus small angle equals big angle. Okay? Yes?
That's a really dumb question, but how did you get 60?
I just made it up.
Oh.
Okay? In order to solve for x, we had to know the measure of the big angle around the outside. All right? Otherwise, we would have had 3 variables in the problem. The only way that you can, well, don't write this, just watch. If I gave you this picture and then something like that, and now, if I asked you to find all those angles, I don't need to tell you what they all add up to, do I? Because you know by definition what they all add up to. Because aren't all of them together form a straight line? Yeah, so in that case you would say, well, x plus 2x plus x plus 1 has to equal 180. Okay? So in that case, I didn't tell you what the big angle was. I told you, but I told you indirectly. You may see it like this. All right, and this is x minus 5, and this is 2x plus 20. But now what do the 2 small angles have to add up to?
90.
Yeah, that's the symbol for 90 degrees, and we haven't gotten that far yet. Okay? I didn't tell you specifically what the angle was, but I gave it to you indirectly. Okay? So you may see it any of those different ways. All right? Got it? Okay. Your assignment for today is going to start on page 24. Problems 1 and 2. Then 4 through 8. Over on the next page, which is page 25, (29 through 31). Let me see if I'm no, let's just stick with this. Let's do 12 through 16. All right, and on Mondays, Tuesdays, and Wednesdays of every week, make sure that you check Edline for homework. Excuse me?
All the others on the board are the practice problems?
Correct. And for third period only, I'm just going to do this while we're here. This is for third period only. I want you guys to add 29 through 31. 29 through 31 on page 25. First period and sixth period don't have to do that, but they're not a pre-ACE class.